Hello viewers, this is Afia Demola Johnson, your chemistry tutor. I want to talk about the number 2 question of likely question for NECO 2024, which is the salt analysis. This year we have been asked to use zinc chloride as our salt. Zinc chloride is ZnCl2. So if zinc chloride decomposes, it forms Zn2 plus, which is zinc ion, and chloride ion. So it means from here we should learn how to test for zinc 2 ion and also test for chloride ion. So the first thing to learn here is test for zinc 2 ion. Test for zinc 2 ion. We need 2 reagents. Reagents needed. There are 2 reagents needed. The first reagent is sodium hydroxide, NaOH solution. That AQ means water has been added to the NaOH. The second one is aqueous ammonia, NH3AQ, ammonia solution. Ordinarily, ammonia is a gas, but when it is dissolved in water, it forms aqueous ammonia, which is also known as ammonia solution. So let us first look at test of zinc 2 ion with sodium hydroxide solution. Now, if zinc 2 chloride is, you add water to it to form, it dissolves inside water, it's a soluble salt, added to sodium hydroxide solution. Now, in drops, that is, you add little of sodium hydroxide, it's going to give you a white gelatinous precipitate of zinc hydroxide, zinc 2 hydroxide. This S means solid. We use solid when the product formed cannot dissolve, is insoluble in water. Then we are going to have sodium chloride in addition to that sodium chloride, which is a soluble salt. Now, this is going to give us white gelatinous precipitate. Precipitate means particles that cannot dissolve in water. So gelatinous means it will be drawing like muco drawing. So now another ion that can form white gelatinous precipitate is aluminium hydroxide. So now that is in drops. Then how do we come about this white precipitate? Don't forget zinc 2 hydroxide is a base, because a base is a substance which when dissolved in water produces hydroxide ion as the only negative ion. But there are 3 categories of bases. We have oxide of metal like sodium oxide, zinc oxide. We have hydroxide of metal like sodium hydroxide, zinc hydroxide, and so on and so forth. Then you have ammonia. But there is something we call alkali. Alkalis are soluble hydroxide. The only soluble hydroxide we have are sodium hydroxide and potassium hydroxide. Every other hydroxide of metal, they are precipitate. They are insoluble. They form certain color of particles like zinc 2 hydroxide Now, what of when you now add sodium hydroxide in excess, you have zinc 2 hydroxide. zinc 2 hydroxide, which is solid white gelatinous precipitate. You now add plus NaOH, sodium hydroxide, in excess. You are going to have a complex salt, ZnOH4. Then you now have you have NaZnOH4. The name of this is aqueous. It can dissolve in water. It's a soluble substance. It's a colorless solution. And the name of this salt is sodium tetrahydroxozincate 3. Sodium tetrahydroxide is hydroxozincate 3 salt. It's a complex salt. So take note of that. That is that about that. So now let's go and see the practical of this. So before we go there, let us see how to test for zinc 2 ion using aqueous ammonia. So with test for zinc 2 ion with ammonia solution, the compound is zinc chloride, which is a colorless solution. And when you add aqueous ammonia, is the same thing as NH4OH, ammonium hydroxide. So if you do it in drops, you add just little. There will be interchange of ions. You are going to have zinc 2 hydroxide, which is also a white gelatinous precipitate. Then you have plus what? You are having ammonium chloride, NH4Cl, which is soluble. Now, so that is what you add there. But what of when you now add aqueous ammonia in excess? You have zinc 2 hydroxide, which is white gelatinous precipitate. You now add NH4OH in excess. What you are going to have is another complex salt, which is tetraamine zinc 2 ion. That is, you have NH3 for zinc 2. Then so you have this ion, zinc 2 ion. So this is aqueous, so this is a colorless solution. So what we are trying to say in essence here, in summary, is that when you add aqueous ammonia in drops and in excess to zinc 2 chloride, in drops it gives you white gelatinous precipitate, then of zinc 2 hydroxide. then in excess, the white gelatinous precipitate will dissolve in excess to form colorless solution as a complex ion tetraamine zinc 2 ion will be formed. So now let us look at how to test for chloride ion. To test for chloride ion inside zinc 2 chloride. Now, in the case of test for chloride ion, you need the following reagents. Now, tests for chloride ion. Test for chloride ion. You see, chloride ion is tested for by converting soluble chloride to an insoluble chloride. There are all chlorides are soluble in water. The only 3 exceptions are silver 1 chloride, mercury 1 chloride, lead 2 chloride. But lead 2 chloride is soluble in hot water. It's only insoluble in cold water. So now, if we have zinc chloride, by the time we add water, it becomes aqueous. They will ask us to add HNO3 followed by AgNO3. When you do that, when you add HNO3, you are not going to see anything, no visible reaction. But the essence of adding HNO3 is to prevent the precipitation of foreign ions. So the active agent here is AgNO3 solution. Now AgNO3, when you now do that, you are going to have white precipitate of of a lead chloride, AgCl, white precipitate. Nothing like gelatinous this time around though, be careful. White precipitate plus what? Plus zinc nitrate. Zinc nitrate. So this is an aqueous solution. So that is that. Now, they can also ask you to that white precipitate of AgCl, add aqueous ammonia, NH3, aqueous ammonia. You will discover that the white precipitate will dissolve due to the formation of another complex ion, which is diamine silver 1 chloride. That is AgNH3 2. Then you have Cl. That's aqueous. This is colorless. Colorless. Why this one is what? White precipitate. So that is that. Now that is that about that. Now, the second, they can also ask you, before doing this one, they can ask you to expose the white precipitate, expose it to light, and observe. You are going to, when you expose it to light, you are going to see the silver metal grayish in color inside the solution. So that is another confirmatory test. So then tests, they can also ask you, instead of using AgNO3, zinc chloride, you can add PbNO3. PbNO3. That's lead 2 triazonitrate 5. If you do that, you are going to get a white precipitate of lead 2 chloride. Solid white precipitate. White precipitate of this one plus what? Plus what? Zinc nitrate. Zinc nitrate, which is aqueous, soluble. So you have that. Now, with this, you can be asked to heat the white precipitate. When you heat, the white precipitate will dissolve. White precipitate which dissolves on heating. Why does it need to dissolve on heating? Because zinc 2 chloride is only soluble in hot water, but insoluble in cold water. So that is that. So let us look at the practicality of what we are talking about in the next video. So please, as you receive this, share this video and subscribe to my YouTube channel so that anytime I post any video, it will reach you. So please, we are going to continue the practical class now of this. I haven't known this theoretical information. I remain my humble self, Afe Ademola Johnson. God bless you and bye for now.